Okay, hello guys. Today our topic is about one-one function and the inverse. Okay, so let's move to the first part. So what is about mappings? So mappings, we are just trying to understand for like here we have two categories. First, we have one-to-one function and many-to-one function. Okay, so for example, like if here we have some data 1, 2, 3, and here's for maybe for 1 for 9, we can say for 1 to 1, 2 to 4, 3 to 9 is 1, 1, right? And also if you have like 1, 2, 3, and maybe you can say 1 and 2 can consider 0 and 3 can consider as 9. So that is many to 1, okay? So last lesson we already learned that a function f represented for changing or like a transformation for a one data or to another data, right? Okay. So here you can just try to draw the graph about a one function and the reverse function. So here for one function, you can consider here like x cube. Okay. So you can say here, if here we have an x cube, so you can find one x represented for one y, right? Okay, that is for one function. So there's only one data represented for another data, right? Okay, that is it. And for many-to-one functions, like here, you can just try to draw the graph like quadratic equations. And you can find here for this x and this is for negative x, they have the same y value. But that is for two data, but they're represented for only one result, okay? That is for like a many-to-one function, okay? So also we can define of the inverse function. Like here we have fx equals to like, for example, like x squared plus 4. So also you can just consider fx as y. So it's y equals to fx equals to x squared plus 4. So we can say like here, the inverse function now can be transient into for x here and there's for y squared plus 4. You can find x and y, they're swapped, right? Okay, so they become new functions, okay? That is it. So also we can set here the not only for x and y, their position is swapped, and here also we can set the domain and the range for function also swapped. Okay. So like here, for example, like here's the steps for this, but now we can just try to give you a working example. Like here, fx equals to 3x minus 1 over 2. So the first step is to just written as y equals to 3x minus 1 over 2. And second step is to swap x and y, so it becomes x equals to 3y minus 1 over 2. And then it's for solving the y, okay? That is for 2x equals to 3 minus 1, and y can be considered as 2x plus 1 over 3, okay? So also you can just try to understand as fx inverse function equals to 2x plus 1 over 3, okay? That is the final answer right here. So here, if you have a domain for x, like x bigger equal to 5, so finally, the inverse function obey the rules for the range and domain are swapped. So here, for the range here is y bigger equal than 5, okay? That is it. And here's another work example, like here, find the inverse function of fx equals to x squared minus 6x plus 5 for x bigger equal than 3. So first we can just written that as y equals to x squared minus 6x plus 5. And then we said, second step is to swap the position of x and y, right? So that is for x equals to y squared minus 6y plus 5, right? Okay, that is it. And now we can just try to simplify it for y squared minus 6y plus 5 as for y squared minus 6y plus 9 equals to x plus 4, right? So left equation can be written that as y minus 3 squared equals to x plus 4. Now you can just like making a root or making a square root on two sides. That is y minus 3 equals to positive or negative square root x plus 4, okay? Then you can write that as y equals to 3 positive and negative square root x plus 4, okay? And here you can find, because we said x bigger than 3 already, so y now here is bigger equal to 3, because we said that their range and domain is swapped. So here is for y bigger equal to 3, okay? That is it. So that is how we can just calculate the exact values for the quadratics right here, okay? That is it. And here is for your exercises. So if you want to try yourself, you can pause the video and do it. But if you want to follow with me, you can keep on going, okay? So let's move into the first part, like find the inverse function of fx equals to 5 minus 2x. So first of the time, we can just write that as y equals to 5 minus 2x, right? And the first step is to swap x and y. That is x equals to 5 minus 2y. So you have rewritten it as y equals to 5 minus x over 2, right? That is the first step. And for second step, finding the gx inverse function for gx equals to x plus 1 over x minus 2, right? So first you can just written down as y equals to x plus 1 over x minus 2, and then swap it, right? It becomes x equals to y plus y over y minus 2, right? And then we can just try to rewrite it, right? So that is for xy minus 2x equals to y plus 1, right? So you can just trying to put y on the one side, 1 times x minus 1 equals to 1 plus 2x. So y equals to 1 plus 2x over x minus 1 right here, okay? That is it. So we can say here, because in this equation, that the denominator cannot be equal to 0, right? So x cannot be equal to 2. Okay, so here we can say y now cannot equals to 2 because the range and domain for the function just swapped, right? Okay. And for the last function, to find the hx inverse function for hx like equals to x plus 2 squared plus 1, right? So we can just trying to first write as y equals to x plus 2 squared plus 1, and then trying to rewritten x and y, right? So x swapped, and for that is y plus 2 squared plus 1. So y plus 2 squared equals to x minus 1. And then you can making square root on two sides, right? So it's y plus 2 equals to positive negative square root x minus 1, okay? So y equals to negative 2 plus negative square root x minus 1, okay? That is it. So that is how we can calculate the exact values right here, okay? That is it. Okay, and maybe for this, we already have the answers, but remember that here is an x bigger equal to negative 2. So here, y must be bigger equal to negative 2, right? Because we said the domain and range also swapped. So here we can only choose negative 2 plus square root x minus 1, okay? That is it. That is for this problem. Hoping you can understanding for how to calculate the exact values right here is very important for you to understand, okay? So that's for today's our lesson. Hope you can understand all of this. See you next time. Bye.